Okay, the third corollary that we didn't get to before lunch says opposite angles of a quadrilateral inscribed in a circle are supplementary. Okay. And if you consider, I mean, we'll just use one example, one angle as an example. If I told you that that angle was 100 degrees, then this arc would be 200, right? The intercepted arc, which leaves 160 of the 360 for the other arc, and half of the 160 would be 80. Because your two angles make up the entire circle, really, the opposite angles, they intersect at the same place, right? So they take up all 360 degrees. So if half of that is represented with this angle, then the rest of the 180 is represented with that angle, the opposite one. So that would be 80 degrees. Okay, because they intercept at the same spot. So we have 3 examples that use these ideas. We'll do the pictures first. Okay, so starting with the top example, looking at angle 1, any ideas on what to do to find angle 1, or what theorem or corollary you might use? The first corollary, or was it the first one? An angle, okay, second one. An angle inscribed in the semicircle is a right angle. So this angle right here, if you have a triangle where one side of it is your diameter, then that angle automatically has to be a right angle. So angle 1 is 90 degrees because it is inscribed in a semicircle. Okay, how about the second one?
some of the things, or are we doing theorems too?
Well, just tell me, where would you start with this one?
38.
Okay, so we have an inscribed angle of 38. If you go out and look at the intercepted arc, then we can get the measure of that, which would be what? 38 times 2. So that makes that 76. Oh, you know what? It would help if I would have drawn this properly, but let's call this a diameter. So we didn't really need all of that. I didn't draw this correctly, but let's.
You just only made like.
Okay, what would this be? If this is a diameter, all of this is 180. So you would subtract it from, you'd subtract 146 from 180. So that would be 34.
Oh, that's last, yeah, 34.
Okay, so this would be 34. And this angle, if you follow that out, that would basically be half of 110, right? Yep. So angle 2 would be half of 76 plus 34. Half of 110 makes that 55. The third one? Okay. This one is the last theorem that we talked about. All right. Where would you start with this? Angle 4. Because angle 4 is the inscribed angle for the arcs of 60 plus 80. So if you add those together, you have 140, which makes angle 4 what? Angle 4 would be 70. Oh, add one more thing here. Okay, if we know angle 4 is 70 degrees, then the third corollary that you wrote down said opposite angles are supplementary, right? So angle 2 should be what measure?
70.
Supplementary, not congruent.
Oh.
110. And what about 1 and 3? Angle 1 is inscribed in a semicircle, and so is angle 3. So they would both be 90. Okay, so you want to look for those semicircles. So they are both 90, and they're both supplementary, so it works. All right. So the last thing we're going to look at, one more theorem and one more example, and then I'm going to give you time to work. Angles formed by a tangent and a chord. Okay, there are two examples of the same type of thing. I want you to draw in chord BC. on both circles. On the circle on the left, we're going to draw the tangent to C, but we're going to draw the tangent coming out to the left. Okay. In the circle on the right, we're going to draw the tangent to C, but going the opposite direction. All right. So the angle formed by a tangent and a chord is half the measure of the intercepted arc. So this, it's basically the same theorem. What's different about this is on the left, you'll see it appears that the arc goes into the center of the angle. So if people have trouble with this, it's usually because there aren't two specific points creating the arc. But you have to figure, when we are talking about the intercepted arc for this angle, we're talking about all of this. Okay, that is the intercepted arc for that angle. And we'll call this ACB. And we'll call that BCD. So the angle ACB, let's assume that this arc is 310 degrees. Then the measure of the angle should be half of that 310. Or 155. Yeah, if this arc is 310, then the angle that we're talking about, that angle there, is 155. Okay. Over here, we have the same situation. It's just that's not an obtuse angle. It's the acute angle made up with the tangent and the chord. So the angle we're talking about is this. And assuming if this is 310, the rest of this would be 50. So if this is 50, then the angle should be 25. Okay. People sometimes second guess this because, again, the arc goes into the center of the angle and they don't think of it as an intercepted arc. But it is. If it's made up of a chord and a tangent, you do have an intercepted arc. Okay, so one last example, and then I'm going to have you guys get to work. So with these, if you start to label what you know, sometimes you'll, even if you don't know exactly where to start, pick something that you have, determine what that gives you, and eventually you're hopefully going to stumble across what you do need, okay? So I would start with the angle that I have a measure for. If this angle is 35 degrees, okay, what does that give me? Arc JL should be 70, right? Okay. JL happens to be an intercepted arc for this angle here, LJK, right? It's one of those that goes into the center of it, but it isn't an intercepted arc because it's a chord and a tangent. So what should the measure of x be? It intercepts the same arc actually as this angle here. So it should be 35. Should have the exact same measure. And we've got a triangle here. Now there's two ways actually that you could find y. Okay? If I know that this is 70 and this is a semicircle, I should know what this arc is. I could find that and take half of it for y. Or I've got another option. Since this is a triangle and one side of it's my diameter, what is this angle?
90.
That should be 90. So you've got two options. I can subtract y from 90, or subtract 35 from 90 and get y, or take half of the supplement to 70, which is 110. Either way, what do you get for y?
55.
Should be 55 degrees. So you've got two ways that you can do that. You can either use the angle inscribed in a semicircle or half of the arc, because we can find that also. All right. So I'm going to give you time to work on that. You can get started. The assignment is 1 through 21.